What's up, everybody? Time to learn how to find some critical values. So let's jump right in here. So during our block, let me just start here, I guess. We took some time to develop the formula for a one proportion Z interval. We also connected that a little bit to our formula sheet. And so hopefully we know that the formula for a one proportion Z interval, we take our sample statistic, which is p hat, plus or minus some critical value, which is our denoted Z star, times the standard error of our statistic, which was the square root p hat 1 minus p hat all over n, right? So during our lesson, we were pretty comfortable. This was the 0.59 that was in the middle of our normal model. This was the square root 0.59 times 0.41 all over 21,248, I think it was. That gave us a standard deviation of 0.0034. And then yesterday, this Z star was a 2 because we were looking at 95% confidence. And so we had to work with 95% confidence, move 2 standard deviations away from the mean. And many of us realize that that number of standard deviations from the mean is a Z-score. So today we want to entirely, or this video, we want to entirely focus on how do we get this blue number, this Z star. We know it's 2 for 95%, 3 for 99.7, 1 for 68. But what if we have 90% confidence, 99% confidence? How can we get that value? So on that note, take a minute here, pause this video, and let's check out this kind of warm-up situation. So we've got a context here, and we want to ultimately try to match some different stuff. We want to know which of these options below is for a 95% confidence interval, which of these options below is for a 90% confidence interval, and which of these options is for 98%. The blue stuff is all the same, so we're really isolating out the red number, the Z star. So pause the video, see if you can match those up. All right, so and now that you've unpaused, and of course you have all the right answers, let's think about this a little bit. With this multiple choice, we can use what we know about the empirical rule and process of elimination to figure some of this stuff out. For instance, for a 95% confidence interval, I can't remember what color I used. We know for 95% confidence, I guess I should match that up to the red picture over here. We know for 95% confidence that we need to move roughly 2 standard deviations away from the mean. So down here, that means our critical value has to be roughly 2. And if we look, that gives us E. So it turns out 95% of the data isn't exactly within 2 standard deviations. Really, 95% of the data, or the sample statistics in this case for a sampling distribution, are within 1.96 standard deviations. 2 is just easier to remember with the rule. If we think about 98% confidence, I guess I'll jump to the blue. 98% confidence here. If we want to be 98% confident, if we look at the blue picture, 95% confidence would be 2 standard deviations away. That's what this is kind of showing here. And 99.7% confidence would be 3 standard deviations away. So if we want to be instead 98% confident here, that's between 2 and 3 standard deviations from the mean, or in other words, that's between 95 and 99.7%. So since 98 is between 95 and 99.7, our Z star has to be between 2 and 3, and that gives us this option here. And then lastly, using that same type of logic, if we want to be 90% confident, 90% is between 68% and 95%. 68% of data or sample statistics are within 1 standard deviation, 95% within 2. So 90%, since it's between those, that means we're going to be between 1 and 2 standard deviations from the mean, or in other words, our Z star has to be between 1 and 2, which means this shows the critical value for 90% confidence. So we can use our logic about the empirical rule to eliminate our options in this case, in this multiple choice scenario. But of course, that still leaves the question, what if it wasn't multiple choice, or how do we actually get that 1.645 or 1.96 and so on? So there are 2 ways to do that. The first option is using inverse norm. To me, the key to this is drawing the picture. So when we're talking about, I'm going to scrap this. When we're talking about a confidence level. Let's say we're talking 98% confident. From our work during the block, we know that a confidence interval is looking between values. So what we're saying is we want to know how many standard deviations do we have to move to the right and to the left so that we are containing 98% between those two values. In order for us to calculate that z-score, or in other words, in order to go backwards from a percentage to a z-score, that's going to require us to use inverse norm. Now, if you have the tail feature on your calculator, this is a little bit easier for you, because if you have the tail feature, you can just choose tail center, and then for this area, you can just put the confidence level as your area, because a confidence level is the amount of area, the percentage, in the middle or between two numbers. So if you have the tail option, you're going to choose tail center. This area would just be your confidence level. So in this case, 0.98. The next thing we got to think about is that mu and sigma are going to be 0 and 1, and that's because those are the mean and standard deviation for z-scores. So if I have the tail feature, I type inverse norm, put my confidence level as my area, choose tail center, enter the mean and standard deviation for z-scores, and this is going to spit out two numbers. It's going to give me positive 2.326 and negative 2.326, and that's just the positive and the negative z-score that cut off the central 98%. So this tells me my z-star is 2.326 for 98% confidence. But that all only works if, what did I do? If we have the tail feature. For those of us who don't have the tail feature, still looking at 98% confidence, we're still going to use inverse norm. But if we don't have the tail feature, this area is always to the left. Mu and sigma are still going to be 0 and 1 because we are still trying to get our calculator to spit out a z-score. But for the area, if we don't have the tail, we have to think about the area to the left. And so there are two ways we can think about that. If we look at this negative z-score over here, this green spot, we have to think about what percent of data would be to the left of this green line. Since there's 98 in the middle, 100 minus 98 leaves us with 2 for the outsides. Cut that in half. That means this is 1%. And in this section over here is 1%. So to the left of this green line, the area would be 0.01. And if I type what's written on my screen in inverse norm, this inverse norm is going to spit out negative 2.326. So that's just the negative z-score, the negative version of our critical value. If I wanted to, I could instead focus on the right side. So if I look at this pink spot right here, for this one, if we go to inverse norm, area, we want to think what is the area to the left of this pink line. And to the left of this pink would be 99%, because we've got the 98% that was in the middle for the confidence level, plus we have this green one over here. So that gives us an area of 0.99. Mu and sigma still 0 and 1 for z-scores. And if I type this pink inverse norm option into my calculator, that's just going to give me our positive z-star, our positive 2.326. And so what this green and pink work is showing me is that 98% of our data values or our sample statistics would be between a z-score of positive 2.326 and a z-score of negative 2.326. Now, to me, it's all about drawing the picture to figure out the area. So if I jump ahead, let's say we were looking at 90% confidence. I think right now would be a good idea to pause the video. We can draw a picture, 90% in the middle, and kind of think about what would you use as your area here for this red spot. If you get it right, you should get negative 1.645 on your calculator. Mu and sigma still 0 and 1 for z-scores. And then if instead we're talking about this blue spot, think about again, if we used inverse norm, what would the area be? Mu and sigma still 0 and 1 for z-scores. And if you do this correctly, you should get positive 1.645. So think about that. But again, I really think the key here is to draw the picture. And now that you've unpaused the video, if you didn't pause it right now, try those. To the left of the red, This would be 5%, because if there's 90 in the middle, that leaves 10 for the outsides, cut it in half. So, whoops, so sorry, to the left of the red would be 5%, so that would be our area. And to the left of the blue would be 95%, because we've got the 90 in the middle on the 5 here. So that's how we can use inverse norm to find the value of Z star. But that's not the easiest option. So most of us, honestly, aren't going to do that. However, there are some questions on the AP exam that will require us to understand how to find Z star with inverse norm, which is why I'm bringing it up. In Unit 7, we're going to have to find some T stars, and some of those might require the use of inverse T, which is the same logic, right? So we do need to know this. However, if we actually have a free response, multiple choice, and we're trying to show the confidence interval formula, we have an easier option. So the other option is to look at what's called a T-table. And so this T-table, which we're going to use heavy in Unit 7. So we'll learn about what this degrees of freedom, this DF stuff means. We'll learn about what this T distribution is. It's kind of like the normal model, whatever, that's coming in the future. But this T-table, which you can find at the back of your textbook, you could Google a T-table. I'm going to give you one in class if you don't have one in your home at break, right? Google it. It looks like this. But what we really care about is this row at the bottom with an infinity. This represents the normal model, or in other words, these are all of our Z stars. So realistically, if we need to get Z star quickly, our best option is just to look at this table. And we can see the kind of answers we referenced before. Like here, if I want 98% confidence, there's my Z star of 2.326. Or if I want 99% confidence, there's my Z star. If I want 90% confidence, there's that 1.645. 95% confidence, there's that 1.96. So realistically, that's the most efficient and easiest option. Take a minute, pause the video, see if you can figure out what would Z star be for 96% confidence. And hopefully you said 2.054. We're really not going to use anything below 90 because, you know, why would we want an interval where we're only 50% confident? So that's how we look at Z star. That's the new stuff. If you want to see an example of how this is going to apply, keep watching. Otherwise, you're good. But if I jump ahead, so now when we do the math section, we're going to have to show the formula for the interval. So for instance, if we have this context here, you can pause the video and read that. Step 1, we would check the conditions. I'm going to skip that. You can do that on your own. You can pause it. I will show an answer on the next slide. Step 2 for the math section. So for the math section, there's going to be 2 pieces to this. We're going to copy our calculator screen. And the reason I want you to copy the calculator screen is because we always have to name the type of test or interval. And if you copy your screen, you will write one prop Z int with the interval below it. But now, in addition to this, we're going to show the formula for the confidence interval. And so in this case, we would need our p hat, which is 0.58. Plus or minus, now we need to get Z star. So for 90% confidence, if I jump back to the previous screen, for 90% confidence, there's my Z star of 1.645. And then we would go back to our standard error formula, which is also on the formula sheet, square root 0.58 times 0.42. Sorry, it's so sloppy, all over 944, which is like pretty much illegible, but hopefully you like listen to what I was saying. And all I'm trying to show here is that now for our math work, we're going to have to show this formula, which is going to require us to look up Z star. We also had one in our homework, number 4, that we skipped the other night. That was an AP multiple choice with the formula. We'll see more of those. Might be a good idea to look back at that now. Maybe grab it, look at the screen, and see which one of those options matches based on the critical value you have to look up and the p hat. It was one about names on USB cables. So that's that. Oh, there's the key, in case you were wondering. And have a great break.